Okay, here we go. We're only going to get through the front side today. And if you notice, we ended with chapter 4. Right now we are starting with chapter 6. We move back and forth between 6 and 5 because I don't like the way that they present it. I think they present it out of order. And I think the people who took trigonometry last year will say that the way that we present it is better. In fact, as I talked with Ms. Rubel, this is the way she chose to do it too. So we're good to go. There are two different ways to measure angles. You can measure them in degrees. You can measure them in radians. Kind of like how when you measure degrees temperature, you can measure in Celsius, Kelvin, you can measure in Fahrenheit. Or if you measure length, you can measure, say, in feet. You can measure in inches. There's a lot of different ways to measure, okay? Same way here. What can you tell me about degree measurement within a circle? There's 360 of them, okay? The way we identify them as degrees is we put that little circle and that superscript up above. That's very important because we don't do that for radians. Doesn't work like that. And we would say that a degree would be, and this is where we start. We start along this line. Talk more about that as we move on. But this would be the, 1/360th, of the circle, or 1 degree. Right? There's 360 of them all the way around. But 360 is a very large number to work with. It doesn't work very well in mathematics, especially when we plot things on the number line. And when we measure in radians, it makes it a lot easier to work with some of the formulas in trigonometry. You need to be able to convert back and forth all the time, okay? And so that's what we have here. Those are degrees. Radians, a little bit different. Radians. The number of radii that wrap around the arc of an angle. The number of radii that wrap around the arc of an angle. This is where it gets really cool. So be ready to be excited, okay? Need a volunteer. Samantha! All right. No, you sit down. Sit down. Sit down. Don't get to come up here. Okay, so Sam, this would be a radius within the circle, right? What I'm going to do is I'm going to draw along the arc. And I want you to tell me when you feel like I've drawn along the arc the same length as what we have for the radius. So for example, Sam, if you stop me when I get over here, that length is a heck of a lot longer than what you see there. Okay, so you tell me. Now I need somebody to confirm whether she's right or wrong. Who's going to judge her? All right, Jalen, you're the judge. Okay, ready, Sam? You tell me when to stop. What do you think, Jalen? Too short, too long, or just right? You think it's just right? She's maybe a little bit long? We'll give you a chance to revise a little bit. How about there? Yep. I would say that that's actually probably about correct. Okay. This is what we would refer to as exactly 1 radian. Here you have 1 degree, which is simply 1/360th of that angle measure all the way around. Whereas this is the angle measure when the arc length is the same as this length. Now, if you were to approximate that angle measure, what would you say is an approximate angle measure for 1 radian? Anybody? 200. No? 90. 60. 60 is a very good approximation. It's actually about 57.2 degrees. Okay? Now, you're not going to work with 57.2 ever. I'm going to show you how to do the conversion, but that's exactly 1 radian is about 57.2 degrees, okay? And that's when, again, 1 radius gets wrapped around. Now watch, okay? I need another. This is where the connections really happen. I need another volunteer. Come on. Charlie, you tell me when I've drawn another one. Another radius. So I'm going to try to draw a second one. You tell me when to stop. I would agree. I think that's pretty good. Nathan, can you do one more? You tell me when to stop. Good. Very good. Excellent, Nathan. It's very smart of you to think that. Look, I can fit one here, a second one there, and a third one there. And I have a little fraction left over. Anybody want to guess how much is left over? What, Ben? 3 point what? 1/4. Yes, he's exactly right. Look at this. How many radii can you wrap around the circle? You can wrap 1, 2, 3.14. How many radii fit into 180 degrees? 3.14. Exactly pi radians fit in 180 degrees. How many fit in 360 then? 2 pi. So if I were to continue this on, just to kind of show you the guys the connection, here's what happens. There I have another one. Here I have another one. And here I have another one. So you can see I have a little bit left over because 6.28 would be 2 pi. So in an entire circle, you fit exactly 2 pi radians. And at 180 degrees, you fit exactly pi radians. And that's the relationship. Notice, what is the formula for circumference? Circumference is equal to 2 pi r. So 2 times pi radiuses fit in an entire circle, which is what we would expect. If your radius is equal to 1, then there's 2 pi is the entire measure around the circle. So that's kind of interesting. So here's what we know, okay? And here's what you can write down, then I'll show you the conversion process. We have exactly pi radians is 180 degrees. We have exactly 2 pi radians is 360 degrees. So that would make this spot here a half of pi, and that would make this spot 3 halves of pi, or 3 pi over 2. So you have a quiz on Wednesday, and it's going to be converting between degrees and radians without use of a calculator. And I'm going to show you right now how to do that. Because when you get to calculus, like my students now, and they don't remember some of their trig, it's very frustrating. It limits them. They can't remember some of the relationships, and it slows us down, trust me. So I want to really impress upon you guys that we remember our trig. And a lot of people forget their trig, but the more you can remember, the better it is. It's just the better it is. So converting between degrees and radians, here's what we do. Theta represents the angle measure. So very commonly, theta is used as a variable. Theta is the Greek letter for TH. They put their sounds together, so you get theta. Looks like an egg with a crack in it, some people say. Whatever. Call it whatever you want. Degrees to radians, here's what we do. We take our angle measure, theta, and we multiply it by pi, and we divide it by, I did that same thing, second hour, sorry. Divide it by 180. That's how we get to radians. Now note, some people get confused with this. Theta here, since we're moving from degrees to radians, theta is in degrees in this scenario. So if you're given, say, 160 degrees, to find out what that is in radians, you take 160 times pi and divide it by 180. How do we get this pi over 180 piece? Well, there are pi radians in 180 degrees. So second piece is I move from radians to degrees. In order to do that, I would take theta, and I would multiply it by 180, and I would divide it by pi. And here, because you're moving from radians to degrees, theta, in this case, would be in radians. Now, with that said, if you're expressing something in degrees, you might see an example of, say, 147 degrees. If you're expressing something in radians, you might see something like 2.16 radians. There is a mark above the degrees. There is no mark above the radians. That's how we could tell what the book is referring to. If it describes an angle measure, for our sake, it must be degrees or radians, and that's how you would tell the difference. Because 2 degrees is very different than 2 radians. So here's a circle we're going to put some marks on. We're going to do some conversion right now, and then you could get started with your assignment. But it says rewrite each angle in radian measure as a multiple of pi. So namely what we want to do is we want to take theta, and we want to multiply that by pi and then divide it by 180. And you could use your calculator to reduce this, but I don't want you guys as much as possible to use your calculator today, because you're going to be expected to do this by hand on Wednesday. Now, there comes a time where if you ask me what is 30 degrees in radians, I know it's pi over 6. I've come to memorize that. But if you ask me 210, I have to do a little bit of math, and I say it's 7 pi over 6. And you guys will get better at doing that. But that conversion process is very important because you'll be asked to move back and forth all of the time. Rewrite each angle in radian measure as a multiple of pi. 0 degrees, as you look at your graph, here's how we classify it. This right here is 0 degrees. This over here is 180 degrees. This up here is 90 degrees. Some people didn't like that first hour. They said that they would want to, they would want 0 to be at the top and then 90 to be here, so on and so forth. It's not like that. It moves counterclockwise, kind of like you would around the quadrants. Namely that this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. So 270 degrees would be down here. So that's just the way it is, okay? That's the way they choose to operate. And as we get to something called the unit circle later on, that will make more sense to you. So let's do a conversion process. We want to take 0 degrees and rewrite it as a multiple of pi in terms of radians. So I take 0, I multiply it by pi, I divide it by 180, and what do you get? 0. So 0 degrees is the same thing as 0 radians. Whereas if I move to 30 degrees, which is this spot right here, now I have a little bit different result. And here's how we do it. We take 30 times pi divided by 180. And I want to write it as a multiple of pi, so let's just forget about actually multiplying by 3.14. 30 over 180, what does that reduce to? Yeah, 1 over 6. So really all we have is pi over 6. So you can see that 30 degrees is also represented as pi over 6. Those are the same. Kind of like 100 degrees Celsius and 212 Fahrenheit. Those are the same temperatures. Okay, now we try 45. So if I go to 45 degrees right here, let's go down here. I have 45. I'm going to need to take 45 and multiply it by pi divided by 180. How many times is 45 going to 180? 4. How do you get that so quickly? 90 and then twice more. Yep, and that's how you got to start to think of things often in terms of 90. So 45 times 2 is 90, times 2 more is 180. So it goes in 4 times. So we end up with pi over 4. So 45 degrees is the same thing as pi over 4. Then I move to 60 degrees. And if you take 60 degrees and you go 60 times pi divided by 180, how many times is 60 going to 180? 3. So we end up with pi over 3. Okay? And 90 degrees. 90 times pi divided by 180 is pi over 2. Very good. So 90 degrees, as we said on our chart before, is the same thing as pi over 2. Let's try one that's a little bit difficult that's not on there. 105. So 105 would actually be right about there. 105 degrees. We try that conversion. 105 times pi divided by 180. Well, let's see, 105 doesn't go into 180, but they're both divisible by what? 5, so let's try 5. 105 divided by 5 is 21, and 180 divided by 5 is 36. So 21 and 36 are both divisible by 3, so it looks like I would get 7 pi over 12. 7 pi over 12. So 7 pi over 12 is 105 degrees. Now, eventually what you guys could do, and I don't want you to do this, you could do this to check your answer, but I want you to do this by hand so you get used to the conversion process in your head, so you get quicker with it. But if I want to check my answer, I could do 105 divided by 180, and if you simply go math and convert to fraction, it will put in its simplest reduced form, which is 7 and then pi over 12. So 7 pi over 12. So your calculator will do that for you. But again, I would like you to try this without your calculator for the time being. And let's try two more. 240. So we can talk about how we do this. 240 times pi over 360. So for this one, I'm going to say 240 and 360 are both divisible by what number? What? I'm sorry. 180. Sorry, did that first hour, second hour. And I'm going to do it again. 240 pi divided by 180. They're both divisible by 60. 240 divided by 60 is 4. 180 divided by 60 is 3. So we get 4 pi over 3 for 240. 240 degrees will be sitting right here. It's 4 pi over 3. And we'll do one more, 360. 360 times pi divided by 180, and you get 2 pi. So please note that as you make a complete revolution around the circle, we end up back at 0, which is also 360 degrees. So those actually have the same spot on the circle. Now, we'll talk about more of this later, but you can continue to go around the circle. I mean, we can have 720 degrees. We can have, 1 million degrees, and they'll have some of the same spots as the other places. But 360 degrees is also the same as 2 pi radians, and that is done and done. So what you need to do here is this. Your assignment is simply this. You've seen how to do the conversion. Please try to use your calculator as little as possible. What I would like you to do is, where is it? Come on. There. Convert degrees to radians every 15 degrees. Make a sheet of paper, a list, start with 0, 15, 30, 45, 60, 75, 90, 105, 120, 135, 150, and do the conversion. You're going to be quizzed on this on Wednesday. Every 15 degrees, all the way up to 360. Go through the process. Try to do it by hand. Begin to study this. Begin to commit some of it to memory. I will not ask you anything other than the 15-degree increments on the quiz, but I will ask you if 360. But I may, if I ask something different than 15-degree increments, that may be possibly an extra credit question. So, that's something you need to be able to work through. So, question, Whitney. No, but I will say this. So, some of you guys don't really even, you're so good with fractions that you don't need to hardly show your work for any of it. But here's what you do need to do. You need to work through them, okay? So don't just simply look at 90 and say, well, that's what we did. We called 90 pi over 2. No, think 90 times pi over 180. And 90 over 180 is like pi over 2. Think of it like that, okay? So start working through that process because I need you guys to get familiar with this so that as we move forward, you know how to do the calculations. Okay, that's your assignment. You will have a more normal assignment tomorrow out of your book, but that's where we pause for today.